What's up, everybody? It's Dan from SageMathTutoring.com. I am back with another video for the Contemporary Mathematics Test Prep, an overview of the various concepts that you need to know. This is part 2 of the overview of concepts, and today we're going to go over voting, all right, the mathematics of voting. So, according to the website, this is all the stuff that we need to know, essentially. We need to know about preference ballots, we need to know about preference schedules, plurality method, Borda count method, plurality with elimination method, pairwise comparison method, as well as the flaws in all the voting methods, the majority criterion, Condorcet criterion, monotonicity criterion, and independent of irrelevant alternatives. One of the things that I've done for this video is I created a flowchart that relates many of the concepts together. Here we can see this sort of column represents the various voting methods, and these parallelogram shaped boxes represent the various fairness criterion that could be violated, and in which case, we'd end up with what could be considered to be an unfair outcome for a particular vote situation. So anyway, we will be reviewing this soon, but I'd like to go over a couple concepts first, and namely the concepts that are first listed here. So what do we have here? So what we have here is preference ballot. So I'm going to put a little star next to that. Preference ballot. That is basically when the voters are asked to rank candidates in order of their preference. So for example, maybe the candidates are A, B, C, and D, and a preference ballot is such that as a voter, there would be a first place, a second place, a third place preference, and a fourth place preference, and you might like B the best, you might like A for second place, D for third place, and the person you really hope does not win the election would be C. Okay, so that right there is a preference ballot. I hope that makes sense. We're going to move on to the next concept now. The next concept is a preference schedule. So a preference schedule is a way of organizing all the preference ballots. So I'm going to provide an example right now. So what I have created here is an example of a preference schedule right here, where essentially you have the voters up top. So it looks like we have how many voters total? 14 plus 10 is 24, plus 8 is 32, plus 4 is 36, plus another one would be 37. So it looks like we have 37 voters. And as we can see from the preference schedule, 14 of the voters ranked the candidates thusly, such that A is in first place, B is in second place, C is in third place, and D is in fourth place. 10 voters ranked the candidates such that C is in first place, B is in second place, D is in third place, and A is in fourth place, and so on. So you could understand that. So this is a preference schedule. It's a really great, compact, succinct way of representing what happened during an election where preference ballots were utilized. All right, so that is a preference schedule. Okay, so now we get into the good stuff where we actually start talking about the various voting methods themselves. And let's focus first on the plurality method. Now, the plurality method basically says, and here it is over here in our chart. In fact, I'm going to blow that up a little bit. So the plurality method basically says that whoever has the most first place votes wins. So let's actually look at a preference ballot and a preference schedule, I should say, right here, and judge it by the plurality method. So as we can see, we have candidate A getting 14 first place votes, candidate C getting 10 plus 1, because C won over here a first place vote as well. So 10 got 11 first place, or C got 11 first place votes. Looks like D got 8 first place votes, and it looks like B got 4 first place votes. So clearly in this case, A would be the winner because A got the most first place votes. So that right there is the plurality method for deciding who would be the winner. All right, so we're going to move on to the next voting method that's in this outline. So really what I'm going to do is just go through these methods, which essentially would be the left-hand side over here. We're going to get into the criterion after that, and I'll kind of talk about how the methods relate to the criterion after that. Anyway, moving on to the next method, which is the Borda count method. Let's look at what the chart says here. So Borda count method, right here, you assign 1 point to the last place winners, 2 points to the second to last place winners, and so on. So it looks like there's a little typo there, but that's fine. So let's see who won by means of the Borda count method. Now, what do I mean by assigning 1 point to the last place winners and so on? Basically what I mean is you could take a preference schedule and extend it as follows. All right, where you're going to assign 1 point for every last place winner. You're going to assign 2 points for the third place. You're going to assign 3 points for the second place, and you're going to assign 4 points to the first place. And I'll even sort of draw this points here. All right, so in a way you're adding another column. That's one way of going about it. And what you want to do is then analyze each candidate. So the candidates are clearly A, B, C, and D, right? Those are the candidates. There's 4 candidates running, and you're going to want to analyze these candidates. So we're going to do one at a time. All right. Now, I will say, I know from experience, it's actually going to be helpful for me to draw these parentheses. All right, where it's going to be like this, and you're going to understand why in a moment. Basically, you ask yourself, how many points are there? And we start from the bottom and we go up until we can't go anymore. You always give 1 point to the last place winner, and then you go up until you can't go any further. So, of course, there are 4 points here. So I'm going to draw 4 parentheses. I'm just going to do that, and you're going to see why in a moment. And I like to always just begin by creating the structure right out the gate. It's a good way to keep things moving and go about things in a way that is relatively systematic and organized. All right, now the question is, what's going to go inside these parentheses? And you'll see that in a moment. But what we're going to do is we're going to, analyze A first. Right? We're going to analyze what happened with candidate A. And we're going to count how many points this person got. So it's really points times voters. All right, points times voters, points times voters, points times voters, and that's going to apply all the way down the line. And we'll start with analyzing, 4 points, 3 points, 2 points, and 1 point. And in fact, you could just do that down the line as well. Okay, and now here's what we want to do. It's points times votes. So the question is, with regards to A, how many, you get 4 points every time you get a first place vote. So you got to ask yourself, with regards to this parentheses, how many first place votes did candidate A get? Well, we had sort of analyzed that before. First place is represented by the top row, and A apparently only got 14 first place votes, right? Or not only, actually that's a lot of first place votes actually. So that's going to be 4 times 14. Now we go to the 3-point column, which is correlated with the second place winning. So candidate A, how many second place votes did candidate A get, and therefore did candidate A get 3 points per vote? Well, it looks like A is not represented at all in that second row. So that's going to be 3 times 0. And then we analyze how many third place votes did candidate A get, and therefore did candidate A earn 2 points per vote. Well, it looks like candidate A is also not represented on this row either, so that will be times 0. And then the question is, how many fourth place votes did candidate A get, and therefore did candidate A earn 1 point per vote? And clearly we can see actually A shows up a lot. As far as fourth place votes, A got 10 plus 8, which is 18, plus 4, which is 22, plus 1, which is 23. So that's actually a fair amount. All right. So that's analyzing candidate A. And what you'd want to do then is you'd want to fill out the rest of this stuff. Analyze candidate B, find out how many first place votes candidate B got, find out how many second place votes candidate B got, how many third place votes candidate B got, and how many fourth place votes candidate B got. So I'm actually going to fill out the rest of this right now. So this is the entire structure filled out. Once again, first place votes are represented by the first parentheses, second place votes represented by the second parentheses, third place votes represented by the third parentheses, fourth place votes represented by the fourth parentheses, and each parenthesis within each parentheses you have the amount of points earned times how many votes the person got. All right, so that's how that works. Of course, you'd have to figure all of this out. You'd have to simplify all this, and I'm going to give you the results right now. So after figuring out what each of these ends up becoming, you then compare the total points earned by each candidate, and whoever has the most points at the end of that whole process wins the election. In this case, it would be candidate B. All right, so B got 106. So candidate B wins. Now, notice candidate B is over here, and candidate B did not get the most first place votes, but at the end of the day, what the Borda count method does is it sort of takes into account all of the preferences of all of the voters, where you can kind of see that people kind of liked candidate B. You know what I mean? Candidate B is represented, let's see, right here. So candidate B in general was fairly well liked. I mean, we have 24 people that listed candidate B for second place. So from what I can tell, the Borda count method is a really good way of making most voters happy. I should really draw that too. This is only one person here. So candidate B had 9 people out of all 37 voters who put candidate B at third place, which could be worse. All right, we have 4 voters here. We have a lot of voters that considered candidate B for second place, so it kind of makes sense that candidate B might win. All right, so that is the Borda count method. And if you think it would benefit you to just pause the video here to really look at the calculations, you might want to do that. All right. Okay, so let's look at the next concept, and the next concept is the plurality with elimination method. So I'm going to erase this. I will put a star near that one. Okay, so the plurality with elimination method is as follows. First of all, let's take a look at what the flowchart says. And according to the flowchart, the plurality with elimination method is such that we note which candidate has the least first place votes. We eliminate them, and then we give their votes to the next person preferred on the preference ballot in that column, and then you repeat until you have a majority winner. So let's be clear on what we even mean by majority winner, because that's a concept that we have not covered just yet. So what we're going to do once again is refer to this preference schedule right here. And as I had briefly mentioned before, we know that there are 37 total voters. And the majority winner would be the candidate or a candidate who has more than half of the votes. All right. So once again, a majority winner would be a candidate who has more than half of the votes. So it's a good idea to get clear on what half of the votes would be. In this case, 37 divided by 2 would be 18.5. Obviously, there is no such thing as 18.5 voters, but we're looking for the candidate that has more than half the votes. So basically, the first time, or if a candidate has 19 voters voting for him, and this is the population of voters that we're dealing with, that candidate who has 19 voters voting for him or her, I should say, is the majority candidate and the majority winner. Now, before you do the plurality with elimination method, it's a good idea to just make sure that none of the candidates are already the majority winner, because if one of the candidates already is the majority winner, then that candidate will have won the election. So we can see that A is the candidate that has the most first place votes, and A only has 14 votes. So therefore, there is no majority winner yet. But once we employ the plurality with elimination method, it is very likely that we will, well, it's definitely the case that we're going to find a majority winner once we apply this method, which we're going to do right now. And we're going to use the same preference schedule right here. So before I do so, what I'm going to do is erase this stuff. But I actually do want to keep this 19 because we want to remind ourselves that 19 in a way is the target. Whoever gets 19 votes is the majority winner, okay? So here is how you do the plurality with elimination method. Similar to the Borda count, you might want to analyze each candidate thusly, where you write it down. And what you're going to do is you're going to ask yourself, okay, how many first place votes did A get? And A apparently got 14 first place votes. How many first place votes did B get? B got, looks like 4 first place votes. How many first place votes did C get? C got 10 plus 1, which would be 11 first place votes. I just had to fix this. I turned it from a B to a 4. Okay, so how many first place votes did D get? It looks like D got 8 first place votes. So we're going to write that down. Okay, so what you do now is you analyze that, and then you ask yourself, okay, who is the candidate that got the least first place votes? And that, of course, would be B in this case. So what you do is you eliminate B, and in fact, you eliminate B everywhere. All right, so B is gone here, B is gone here, B is gone here, B is gone here, B is gone here. And then you analyze the next round only without B. Now, it's a good idea to rewrite the preference schedule with the same numbers across the top first and kind of rewrite it only without B. Okay, so this is going to be A, C, D now. This is going to be C, D, A now. All right, this is going to be DCA. This is going to be DCA as well. And this is going to be CDA. And then you perform the exact same analysis. So for round 2, we have the following. Looks like A got 14 still for the first place votes. Analyzing how many first place votes C got, looks like it's 10 plus 1, which is 11. And when it comes to how many first place votes D got, it looks like it's 12 right here. So we're going to write that down. It's still the case that none of the candidates have reached 19 yet, so we don't have a majority winner just yet. But we're still going to follow through with that same process where we take note of the person with the least first place votes. In this case, it's C, and we're going to eliminate them from the competition. So we are now eliminating C, and we're going to do it from here this time. And then we end up with the following preference schedule. So after C has been eliminated, we're going to have A, D. We're going to have DA. we're then going to have dA. dA again, and finally dA again. And at that point, we'll analyze A and D now. All right, so we went from here to there, because in the last round we had eliminated C, which is denoted here. This is our new preference schedule. So how many first place votes did A get? Well, A still got 14. And D got, let's see, 10 plus 8, which is 18, plus 4, which is 22, plus 1, which is 23. And therefore D is the majority winner with 23 first place votes, seeing as how you need 19 or more to be the majority winner. D is therefore the winner. So that's plurality with elimination method. Now notice the words plurality has everything to do with the candidate that has the most first place votes. We had discussed that before. That's what plurality means, right? The plurality winner is the winner with the most first place votes. However, this is the plurality with elimination method, so the second word is elimination, and that is part of the process. We eliminate, in each round, we eliminate the candidate with the least first place votes. We repeat that until we have a majority winner. So that's the plurality with elimination method. Okay, so that covers the plurality with elimination method. And now we're going to go to the pairwise comparison method. And this one has to do with head-to-head competitions. Like, for example, in basketball, you know that you can have one-on-one basketball games. Well, that is, in a sense, what you're going to be doing with the pairwise comparison method. You're going to take each of the candidates and you are going to have them do a one-on-one competition with each other. And here's what it looks like. Okay, so the first thing you want to do is you want to ask yourself how many one-on-one competitions will there be? And that depends on how many candidates you have, and in this case, we have 4 candidates. You got A, B, C, and D. And a way to calculate how many total competitions that you'll have is to employ the following formula. You could take the amount of candidates that you have, multiply it by the next number down, and then divide that by 2. Okay, that's how you do it. So this would end up becoming 6. All right, so there should be 6 total one-on-one competitions that we need to take into account. All right, so that is a trick of the trade that might come up. I hope my student realizes the usefulness of that, and just to put it in more abstract terminology, it could be something along these lines. It's really a combination situation, but it's the number of candidates times that number minus 1 all over 2. That's how many competitions you're going to have if you take into account one-on-one competitions. And what are they? Well, first of all, it would be A versus B, A versus C, A versus D, and then you're going to have B versus C, B versus D, and after that you would have C versus D, and finally you would have, actually that's all, that's 6. Okay, so C versus D. Now keep in mind the order doesn't matter. A versus B is really the same thing as B versus A, right? So this is a nice lineup. And what we're going to do now is analyze, who wins in these one-on-one competitions. And here are the rules. Whoever wins in the one-on-one competitions gets 1 point. And if there's a tie, then each candidate gets a half a point. All right, so that's how this works. So let's compare A and B. And essentially, to find out the winner, you ask yourself who ended up on top in each column. So we have A and B right here. A ended up on top 14 times in this column. Right? So A so far has 14 wins against B. And what I'd like to do is actually analyze how many wins A gets first. So A has 14 wins in the first column. And looks like B wins in the second column, looks like B wins in the third column, looks like B wins in the fourth, and it looks like B wins in the fifth column. So A doesn't have any more wins, but let's analyze how many wins B has in these other columns. So we have 10, B beats A here 10 times, B beats A here 8 times, B beats A here 4 times, and B beats A here 1 time. So that's going to be 10 plus 8, which is 18, plus 4, which is 22, plus 1, which is 23. So B wins over A 23 times. So B in this lineup is the winner with 23 versus 14. So B gets 1 point. All right, 1 point for winning. Okay, analyzing A versus C. So we're going to look at victories that A has over C. A beats C here 4 times, and A loses in all of the rest of the columns. So actually, once again, it would be A getting 14 points, and it would be C getting 23 points for the exact same reason that B got 23 points. And therefore C gets 1 point because C is the winner of that head-to-head comparison. And it's going to be the same thing with A versus D. A is going to get 14 points, and I know that for sure because A got first place in this column, and A got last place in every other column. So this is essentially going to be a repeat of the same scenario. So D gets 23 points because D totally beats A here, beats A here, beats A here, beats A here, and 10 plus 8 plus 4 plus 1 is 23. So therefore D gets a point. All right, D gets a point. Okay, now it gets perhaps a bit more interesting, B versus C. So B beats C here, so that's going to be a win for, I'll even circle it actually. So B beats C here. B does not beat C here. B does not beat C here. B does beat C here. And B does not beat C here. So what I'm going to do is write down the fact that B gets, let's see, B won only in this column and in this column. So that's going to be 14 plus 4, which is 18, right? And D would win all these empty columns. So that's going to be 10 plus 8, which is 18, plus 1, which is 19. All right, so D gets 19. So D gets more victories over B than B has victories over D. So therefore D would get 1 point there also. All right, looking at the lineup of B versus D right now, and let's erase this stuff right now. Okay, and at first, once again, we're only going to analyze how many victories B has over D. We're going to focus on that. So looking at the first column, B definitely has a victory over D there. Looking at the second column, B has another victory over D there. B does not have a victory over D here. B does have a victory over D here, and B does not have a victory over D here. So let's count just the columns that have yellow in it. That's going to be 14 plus 10, which is 24, plus 4, which is 28. So B gets 28 victories there. Now, to find out how many victories D has, you just add up all the numbers at the top of each empty column. So that's going to be 8 plus 1, which is 9. So D gets 9 victories over B. B is the clear winner in this case, so therefore B gets 1 point. 1 point. All right, and finally, C versus D. So let's analyze how many victories C has over D first. So looking at the first column, C does indeed beat D here. C beats D here. D beats C here. D beats C here, and C beats D there. So as far as victories for C, we are looking at 14 plus 10, which is 24, plus 1, which is 25. So that would be C getting 25 victories. And with regards to D's victories over C, that would be all the empty columns. We're looking at 8 plus 4, which is 12. So D gets 12 victories over C. And in this case, C is the winner. So C gets 1 point. Now keep in mind, I want to remind everyone watching, and I also want to remind my student, that had there been a tie in any of these matchups, then each candidate would get a half point. Okay, so at this point, what you want to do is you want to analyze, how many points each candidate ended up getting at the end of the day, all right? So how many points did A get? Well, honestly, A got no points. So A got his or her butt kicked. B, let's see, B got 1 point here plus another point here. So that's going to be 2 points for B. C got 1 point here and 1 point here. So that's going to be 2 points for C. And finally, D got 1 point and 1 point here. So that's going to be 2 points for D. So as you can see, we have a tie between these three candidates. Now that will happen occasionally with the method of pairwise comparisons, but the people who create these elections know that this is a possibility, and it's often the case, or always the case, that there is a predetermined tie-breaking procedure that is employed in case there is indeed a tie. Now, it could be the case that multiple winners are allowed, right? And in that case, these three would be the winner. So that is the pairwise comparison method for voting right there. Okay, so now we're going to look at the flaws in all voting methods. Now, in order to understand whether or not there is a flaw in a voting method, you're going to need to know what the fairness criterion are. Okay, so the fairness criterion are the majority criterion, the Condorcet criterion, the monotonicity criterion, and the independence of irrelevant alternatives criterion. So I think I would like to look at this flowchart for that. So we're going to go over each criterion one at a time, each criteria one at a time. So we have the majority criterion. What this says is that basically, in order for a voting method to be fair, it should be the case that if more than half the voters vote first place for a candidate, then that candidate should win. So again, this is a general idea of what is quote-unquote fair. And that's fairly intuitive. In fact, all of these criterion are fairly intuitive. And the majority criterion is something that we have already discussed. So again, just giving you a brief overview of each of these. Now, there's another criterion called the Condorcet criterion, and that says that the winner of one-on-one competitions should win the election. Okay, so if you team up or have each candidate compete in a one-on-one fashion, whoever is the winner of the one-on-one competitions should win the election. Now, obviously, we just did the pairwise comparison method, voting method. Clearly, that satisfies that method of voting. The method of pairwise comparison satisfies the Condorcet criterion. So that is Condorcet criterion. The next one is the monotonicity criterion. And what that says is that if candidate X is a winner, and in a re-election the only changes are changes that favor X, then X should remain the winner. Now, of all the fairness criterion that I've mentioned so far, this is the one that I think needs the most explaining, because this could sound just like a bunch of gobbledygook here, whereas what we just talked about with regards to the Condorcet criterion and the majority criterion. The description of these is fairly straightforward. This one is a little bit different. So I'm going to present an example of how the monotonicity criterion could in fact be violated occasionally. So imagine we were dealing with this preference schedule right here, and we were using the plurality with elimination method. All right, so in fact I'm going to write that down. We were using the plurality with elimination method. All right, I'll just call it plurality with elimination. Now, if we were to go through the motions of plurality with elimination, which basically means you find out who has the least first place votes, and you eliminate that candidate, and then you move into another round where you essentially repeat that process until you have a majority winner. If you were to employ this method that we have already discussed before, then C would win. C would win. Now, one of the flaws with the plurality with elimination method is that it can occasionally violate the monotonicity criterion. Because, for example, imagine we had a re-election that had the following preference schedule. Now, if you look at the difference between this preference schedule and this new preference schedule, basically what happened is these four voters switched over to this preference ballot. So I'll draw a little arrow. These four voters decided that they, you know what, at the end of the day, they like C the best, and they like A second, and they like B the third. You could also think of it as them switching these around, right? So they like C the best and A the second. So in a sense, they switched over here where they like C the best, A second, and then B third. So this is the new preference schedule. Now notice, since these four voters decided to switch A and C, and therefore they're sort of hopping onto this train, and therefore we now have 14 people who like C the best, A second, and B the third. Clearly, that is something that should benefit C, right? I mean, C won the first election based off of the plurality with elimination method here, and then there was a re-election, and the only changes that took place are changes that benefit C, who was the winner the first time. So clearly C should win this time, right? Well, interestingly enough, when you use the plurality with elimination method, occasionally it will be the case that C won't win. The candidate that was the recipient of changes that should favor that candidate ends up losing the election, because basically I'll leave it up to you to do the plurality with elimination method on this to check for yourself. But what you will discover is that if you do the plurality with elimination method on this preference schedule, you will discover that B would win. All right. Now, actually, it would be a good form of practice for you to actually use the plurality with elimination method on this to just confirm that B would win, even though the only changes that took place between this preference schedule and this new re-election preference schedule are changes that benefited the previous winner. So according to the monotonicity criterion, that should not happen, okay? In order for a voting method to be fair, this should not happen. Now, it does happen occasionally when you use the plurality with elimination method, but in doing so, it violates the monotonicity criterion, which says that this should not happen. All right. Now, again, I'll give you a little preview for what's to come. There is no voting method that is perfectly fair, in case you're asking that to yourself. Because of course you might be asking yourself, okay, well, why are we using the plurality with elimination method when clearly it will occasionally violate the monotonicity criterion? Well, part of the answer is because there is no voting method that doesn't violate some fairness criterion. Okay, so that's important to keep in mind. Okay, so moving on to the next fairness criterion, and that would be the independence of irrelevant alternatives criterion, which says that if candidate X is the winner of an election and in a recount one of the non-winning candidates withdraws or is disqualified, then X should still remain the winner of the election. Now, in a way, this is somewhat similar to the monotonicity criterion, where according to the monotonicity criterion, if X is the winner of an election, and then the only changes that take place after the election, before the re-election or before the recount, are changes that favor X, then X should remain the winner. Well, in a somewhat similar fashion, what the independence of irrelevant alternatives criterion is saying, that it's essentially saying that if X wins, like the first election, and a non-winning or a loser candidate leaves the election process before the recount, then X should remain the winner even after the recount. Okay, so similar to the monotonicity criterion, I'd like to illustrate yet another example. At least an example of what it looks like, or what it might look like when the independence of irrelevant alternatives criterion is violated. So imagine we were dealing with this preference schedule right here, and we were going to use the method of pairwise comparison. So before, with the monotonicity criterion up here, we were talking about the plurality with elimination method, but now that we're talking about the independence of irrelevant alternatives criterion, we are now going to look at what can happen when you use the method of pairwise comparisons when determining the winner of an election. So I'm going to write pairwise comparisons right here. And if we were to use the method of pairwise comparisons, then the winner in this case would be A. Now, if you want to pause the video and work out the pairwise comparisons method on this preference schedule, you could confirm for yourself that the winner would indeed be A. And again, pairwise comparisons has to do with head-to-head competitions between all the various candidates. So again, if you want to pause, you could always do that. Now, let's imagine that there's a recount or a re-election, and then we end up with the following preference schedule, which I'm going to fill in right now. But before I fill it in, one more detail, and it's actually a very important detail. Before I fill in the next preference schedule, we need to just recognize that C has left the competition. All right. C has left the competition. So I'll do a little asterisk. And now we have a new preference schedule after C, who, by the way, didn't even win the first election. During the recount, before the recount, C has left the competition. So here's the new preference schedule. So the new preference schedule, of course, no longer features C in the competition, right? And now, in this case, B would win. All right, B would win if we were to use pairwise comparisons again with the new preference schedule. So I'll put a circle around B. So in other words, during the first vote and the first preference schedule, A was the winner. C left the competition. There was a recount. And after that, B wins. So the fact that A is no longer the winner, even though a loser candidate left. So A won, a loser candidate left, and then there's another vote, and then B wins, you know. How could that be? You know, that doesn't seem to make sense. That doesn't seem to be fair. So that is a nice illustration of the independence of irrelevant alternatives criterion. And basically, this flowchart that I made really shows the relationship between the various voting methods and the various fairness criterion that each method might end up violating. And let's kind of look at that right now. So the plurality method, which again says that whoever has the most first place votes wins, that can, it doesn't always violate, but it can violate the Condorcet criterion. And the Condorcet criterion once again says that it's not necessarily the person with the most first place votes, in the first round of voting who should win. It's, the winner of all of the possible one-on-one head-to-head comparisons should win, right? So the plurality method violates this one, okay? And let's look at the Borda count method. So the Borda count method, where you assign 1 point to the last place winners, 2 points to the second to last place winners, and 3 points to the the next up in line. The Borda count method actually can violate the majority criterion and the Condorcet criterion. So the Borda count method could violate the majority criterion that says that more than if a voter gets more than half, or I should say if a candidate wins more than half of the voters' votes, and we're talking about the total population of voters, then that candidate should win the election. Now, the Borda count can definitely violate that, all right? And to be more precise, if more than half of the voters vote first place for a candidate, that's what I should say, first place. Now, notice how the Borda count, if you recall when I talked about it before, it doesn't stress too much who the first place winner is, right? It has more to do with tallying the points that each candidate gets based on each preference ballot and the preference schedule. The Borda count method could also violate the Condorcet criterion. Condorcet criterion, once again, stresses the importance of head-to-head comparisons and who would win the head-to-head comparison. Okay, so looking at the plurality with elimination method, let's look at that. That can violate the Condorcet criterion, and the plurality with elimination method could also violate the monotonicity criterion, as we actually saw, right? We demonstrated that. So again, the plurality with elimination method, it has everything to do with figuring out who has the least first place votes in the first round, eliminating that candidate, and then repeating the process until you have a majority winner, until you have somebody who fulfills the majority criterion. So the plurality with elimination method can violate the Condorcet criterion, and it can also violate the monotonicity criterion, which says that if candidate X is the winner and in a re-election the only changes are changes that favor X, then X should remain the winner. Okay, so that is the plurality with elimination method. The pairwise comparison method violates the independence of irrelevant alternatives criterion. And when I say violates, again, I want to stress that it could violate. It doesn't always violate it, but it could violate it. And a quick review, pairwise comparison method is when actually you have each candidate go head-to-head, and 1 point is assigned to the winner, a half a point is assigned to a tie. And the independence of irrelevant alternatives criterion is such that if a candidate X is the winner of an election and in a recount one of the non-winning candidates withdraws or is disqualified, then X should still win the election. So I have a feeling for my student, or I should say that my student is not going to have to deal too much with the details of all of this. I do believe that she will need to know the various fairness criterion that each of these voting methods violate. So I do believe it's important for my student to know which fairness criterion, for example, the plurality method violates, and in this case it would be the Condorcet. I believe it's important for my student to know which fairness criterion is violated by the Borda count method, namely the majority criterion and the Condorcet criterion. I believe it's important for my student to know which fairness criterion the plurality with elimination method violates, and that would be the Condorcet and the monotonicity. And finally, I believe it's important for my student to know which fairness criterion the Pairwise Comparison method violates, and in this case is the independence of irrelevant alternatives criterion. That is something certainly worth memorizing for sure. So we have actually covered everything basically. So preference ballots, which are the ranking of various candidates, preference schedules, which is a way of summarizing preference ballots, the plurality method, which is mentioned here, the Borda count method mentioned here, the plurality with elimination method, which is mentioned here, the pairwise comparison method, which is mentioned here, and all the flaws in the voting methods, the majority criterion, which is here, Condorcet, which is right here, monotonicity, which is right here, and the independence of irrelevant alternatives mentioned here. We also talked about the various ways in which each voting method has the potential to violate one of these criterion. Now, there is another concept worth mentioning before I end this video, and that is the following concept: Arrow's impossibility theorem. Okay, so I had alluded to this before, but essentially what my student needs to know, and what those of you who are taking the contemporary mathematics test need to know, is that Arrow's impossibility theorem states that it's mathematically impossible for a democratic voting method to satisfy all of the fairness criteria. So in other words, as good as all of these methods are, and as intuitive as many or all of them are, it's literally impossible, mathematically speaking, to satisfy all of these fairness criterion. And, the fairness criterion is intuitive as well. So that is an interesting fact about the mathematics of voting, is the fact that it's ultimately futile to attempt to discover a voting method that doesn't violate at least one of these. Okay? And the proof of which is beyond the scope of this video, but it's important to know that. Anyway, I hope you enjoyed it. For my student at home, I hope it was very helpful. I know it's a lot of information, but we're going to keep breaking these videos up one at a time, and I will see you in the next video.